Welcome! Today I will take you on a journey to learn the inner workings of relational division in SQL. Let's suppose you are an aspiring astronaut looking to make your mark on the universe. You take the first step and apply to be an astronaut for NASA. You send your resume highlighting all of your most valuable skills. How will NASA know that you, and only you, are the right candidate? Let's suppose NASA receives and reads your application, storing your information into their database. This database consists of two tables. First, the applicant table, which contains the names of each applicant paired with the skills listed on their resume. The second table lists the skills NASA desires from applicants. NASA wants to find applicants who have all of the desired skills. In relational algebra, this task could be easily performed using division, an operation that figures out which records in a set are related to all records in another set. Let's see how this would work in our example. Here, we are checking to see if each applicant is adaptable and educated. We see that all applicants are adaptable. Here, Ryan is also educated, so he has all the desired skills and is moved into our result. John is also educated, so he will be moved into the result as well. Mike is not educated, so he will not be moved into the result. Now we have a list of applicants who have all the desired skills. So how do we translate this operation into SQL? Unfortunately, there is no native division in SQL. However, like most things in relational algebra and SQL, there's many different ways to achieve the same result. Thus, we will try to rewrite division using operations that are supported in SQL. Returning to our original tables, let's think about how we could achieve this. First, let's simplify our example by renaming the applicant and skill tables to A and S respectively. Let's also remove the rows from our applicant table that did not play a role in the division operation. Now, looking at the applicant table, you may notice that it looks very similar to a cross product of the distinct names in A with the skills in S. Let's use this fact and see what the full cross product between the names in A and the skill table would look like. Here you can see that the cross product has all possible combinations of applicant with desired skills. What we can do now is subtract the applicant rows from this table. This will leave us with all the applicants that do not have all the desired skills. In this case, we'll be left with Mike and educated. From here, it is simply a matter of taking the distinct names from A and subtracting the distinct names from our result. So let's perform the subtraction, and you will see Mike is removed. Now we are left with the exact same result as if we used the original division operator. Now that we have rewritten the division using operations that can be written in SQL, let's translate the relational algebra to SQL. Let's work through this query from the inside out. First, projecting name out of A. In SQL, you can do this by selecting the distinct names out of A. Now we need to get the cross product of these names with the skill table. We can do this in SQL by performing a cross join across the skill table and distinct names. As you can see, this will get us all possible combinations. Next, we want to select A again, so we can perform the subtraction that is in our original query. Here we will use the except keyword to remove all rows from the result that are in A. After the subtraction, we are left with Mike and educated as we had before. To make our SQL a little more clean, I'm going to alias this result with using a with clause. Next, let's project names out once again. And now we just need to perform the final subtraction, getting the names out of the original applicant table and subtracting the names without all desired skills. So let's perform the subtraction. Wonderful! We have now achieved the exact same result as our original relational algebra statement. It is important to note that this is just one way to implement division in SQL. I will show you two more ways using correlated subqueries and aggregate functions. As an exercise, I would recommend you pause the video and see if you can figure out how they work. Although you may not be an astronaut, you now have the knowledge to implement relational division in SQL. Thank you for watching, and feel free to ask any questions in the comment section below.